We're going to refresh your memory on how to do correlation. Now, this is another process that's done in your calculator, so you will need your calculator because I want to make sure that everybody has refreshed their memory on the process, how to go about doing this. So please have your calculator out. And we are talking about correlation. Okay? So, to start, correlation is used to determine the strength of your data's relationship. Okay? So when you're comparing two pieces of data, such as height and shoe size, for example, okay, correlation basically told us how strong those two things were actually related to each other. Okay? And it was associated with a numerical value called the Pearson moment product correlation. That's like its official name. Okay, Pearson moment product correlation coefficient. It was represented by a letter. What was that letter? R. Okay, it was a lowercase r that represented that number that basically told you the strength of your data relationship. And so when we typed it in, okay, because for test purposes, you need to know how to do this in your calculator, not by hand. IAs, you had to do it by hand. The test is all calculator. When you type everything in and you get a number associated with R, it could either be between 0 and 0.25, between 0.25 and 0.5, between 0.5 and 0.75, between 0.75 and 1. And that told you the different types of strength. It was between 0 and 0.25. That meant it was what? Not just weak, but very weak. And it was in between 0.25 and 0.5, it was weak. It was between 0.5 and 0.75, it was what? Moderate. And if it was between 0.75 and 1, it was what? Strong. Now, if it equaled exactly 1, that meant what? If it was 1, that meant it was what? Another name to describe this relationship.
Proportional?
It does start with a P, though.
Perfect.
If it was equal to 1, it was perfect. And if it was equal to 0, that means there was zero correlation, no correlation. Okay? So how you do this, okay? Of course, we're dealing with the statistics unit. So we would have to type in all of our data that we would have. So we would go where? Stats. And we would type in our data into L1 and L2. But in order to find our correlation coefficient, we would have to do what? We would have to go to line reg. And how do I get to this screen right here? That top screen. How do I get there? I go to stat, and then I go over to calc. So I press the stat button, and then I move over to calc, and then I go to len reg. Now, after you do that, your calculator could look like mine right here. If that's the case, then you pretty much type in L1 is your x's, L2 is your y's. Your frequency list is always in your L2, or it should be in your L2. You can store your equations, that's fine. Of course, we went over this the other day. Maybe refresh your memory. How do I get Y1? What do I do?
You mean L1?
No, the Y1.
Oh, Y1.
Maybe I did. Maybe that was another class. How do you go to store your regression? You go to no, not catalog. Good. You go to vars. Everyone click on their vars. Then you go to Y vars. Then you go to you click vars, you go over to Y vars, then you go to. Have we ever dealt with parametric polar at all? Ever? No.
Never.
We've only dealt with what type? Functions. So you go to functions, and there's Y1. Okay? All right. Now when you go down and you go to calculate, once you click enter, you'll get Y1. When you go to calculate, your R should pop up.
It didn't do anything.
You gotta go to calculate. All right, you have to have L1 and L2 in there. Okay? Now, that's of course if you have data in there. Now, if you're dealing with a calculator that has no data, you're not going to get anything. Okay? You gotta have data in there. All right? So we're going to look at an example where we actually going to type in some data. We're going to go through these processes, a very simple one, and then we'll see what we get. Yes. If your calculator looks like where it just pops up, where it just says Lynn Reg. Okay. If yours looks like Artney, where it just pops up like this, what goes first?
L1.
L1. Okay. You do L1, and then you have to what?
Comma.
Then you have to do comma. What comes next?
L2.
L2. And then what?
Y1.
Comma. And then you go through the whole process to get your Y1. Okay? That's what it should look like. L1, L2, and then Y1 with commas in between. If the question asks you to predict something, like a future value or something like that, then you would want to have your thing stored. You do want to have your equations stored. Because when you do click enter, not only are you going to get your correlation coefficient, but you're also going to get the equation for the regression line or the line of best fit. Like they went together, okay? They all went together. So not only do you find your correlation coefficient, but you also find the equation of your regression line. And you use the regression line when they are strong or moderately strong. Okay? So, let's look at this first example. We'll look at this one together. It says a survey investigated the relationship between the number of cleaners in and the amount of time T it takes for them to clean the school. You do not have to write this problem down. If you want to get it, though, you can always go back and watch this video. So we have the number of cleaners in and the time in T minutes. We're going to use our graphic display calculator to write down the equation of the regression line and to write down the Pearson product moment correlation coefficients. So where do I go?
Stat.
I go to stat, and then I go to what?
Edit.
Go to stat, and I go to edit. And I have to type in my data. What goes in L1?
1, 2, 3, 4, 5, 2, 3, 5, 6.
The 1 through 6, the number of cleaners. What goes in my L2?
The time.
The time. So I'm going to go ahead and give you guys a second to put that in there, and then we'll continue. So now that we got our data in there, we are looking for our regression line and our correlation coefficient. So we got to go to what? Stat, calc, option 4. Now again, if your calculator looks like mine, everything is already stored in there from the last time that we did it. But if yours look like Artney, remember, it's L1, comma, L2, comma. Exactly. So right here for store regression equation, I got to go to vars, y vars, function, y1. Y1 is basically going to take the equation and store it into our y equals for us, the non-rounded answer.
But what if we have calculator like Artney?
The same way, you go to vars, go over to y vars, go to function. Are we all good? Everyone ready? Okay. Say again. That's the same way. If there's extra data, you want to make sure that you clear your list before you start typing in stuff, okay? All right, so we're getting different things. Let me go back through it again. Stat calc, option 4. The only other thing I can think of that I'll fix, let me get rid of this. Maybe that's what's the difference. Okay, so all I did was I clear out my frequency list. So if yours looks like mine, go ahead and clear out your frequency list. Make sure there's nothing there. All you got to do is click delete or clear on that. Actually, no, click delete. Click delete. So when I go to calculate, does ours look the same now?
No, yours is different now.
Okay. So what we need, so if yours looks like mine, then you got to make sure that your frequency list is clear. You got to make sure your frequency list is clear. Okay?
How'd you do that again?
So I just, when it said frequency list L2, I just put clear, so there was nothing there. Okay. So now our equation, it sets it up for you, okay? My equation from our regression line is what? Y equals what? 205? Okay, that is the rounded answer there. That's what you would write down. Now, I'm glad my calculator did this because I should also be seeing my correlation coefficient. If your calculator actually has the correlation coefficient, that's great. But when you get that calculator on the day of your exam, it's going to do exactly this. You've got to make sure that you turn on your correlation coefficient. When your calculator gets reset, it goes back to its standard default settings, which means your calculator is going to look exactly like mine. So when you get your calculator on the day of your test, you're going to have to turn on your correlation coefficient. And I'm going to go over that. Yes,
Catalog thing you showed us?
it was the catalog thing I showed you,
Use a diagnostic.
and it was diagnostic. So if you do not have the R, and even if you do, practice this. Get this engraved in your mind. You press the second button, then you press the 0 button. It takes you to the catalog. This is where all the stuff lies if you forget where something is. And because I need to turn my diagnostic on, I'm going to click the X to the -1 button. This button right here. It is 2 buttons underneath the green button. It's highlighted in red. Everybody see that? Then I'm going to scroll down to where diagnostic is. And I want diagnostic on. And I'm going to enter and enter it again. So now when I go back through and I do the same process of stat, calc, option 4, everything good. I'm going to go back, store my Y1. And I calculated, I will now have my R. And what is my R? -0.941. Which means that it has what kind of correlation?
Strong negative.
Strong negative. It doesn't ask that, but it's good to know, okay? Now it says use your regression equation to find the amount of time 4 cleaners take to clean the school. What would I do there? You plug 4 into the X value, and you can solve it out that way. Or if you like, you can go to your table and go to where it says 4, and you will figure out exactly how many or how long it took for 4 cleaners to clean it. That is true. That is true. Okay. So we can go. I'm not even gonna lie. I'm quite happy that you all said that. Okay. What is your value? Yes. So round of 3 significant figures would be 124 or 125? 125 minutes. Okay? And that's the same thing you would get if you went and looked at the tape. Are you sure it's 125? Oh, that's right, because we used the rounded answer. That's why. I remember the regression equation is stored the non-rounded answer in your calculator. So it's going to give you the non-rounded answer there. Okay? All right? All right, do this next one on your own now that we refreshed your memory. Actually, just write it down on your sheet of paper. Do this one real quick. So statements 1, 2, 3, 4, and 5 represent descriptions of the correlation between 2 variables. Which statement best represents the relationship between the 2 variables shown in each of the scatter diagrams? What about A? Which one is it? Low positive. Very good, okay? It is going in the upward direction, so it's definitely either 1 or 2. And the thing is that it has a low positive linear correlation, okay? If it was high, it would be a little bit closer together. What about B?
High negative.
It would be 5. High negative. Very good. What about C?
No.
3. When it's scattered like that, there's no correlation. And D?
1.
High positive. Very good. Now again, remember, not only does the process through your calculator with Lin-Reg give you the correlation coefficient, but it also gives you the equation for your regression line. Okay? So, regression line is basically the most exact way to get your line of best fit. Your line of best fit is the line that goes through your data, where some of your data is above the line, some of your data is below the line. Okay? Take that last example that we just did that's still stored in your calculator. If I went to Zoom Stat, oh no, did I press Stat? Hold on, give me a second. Delete this. Turn this on. Delete. Turn this on. If I go to Zoom Stat, there's my data, and there was that regression line. Okay? That is the best line, the line of best fit for this data, the one that's the most exact. Okay? Give me a second. All right? Now, when you actually have to draw that by hand, you can go through and you can type in your data. You can go through the same process we just did, okay? But you want to make sure the one thing is true. That line goes through your mean point, okay? So when we look at this example, consider the following x and y values on the scatter plot, which represents the information given in the table. We have to write down the value of A and B. Look at this graph. What's going to be the value of A? Is it 5 or is it 8? Exactly. You see that right there? They already have the 5 taken care of, but they don't have the 8. Now let's try to find the value of B. What's the value of B? The value is... All right, look at the table. The table says when x is 1, what is y? So you go down and you look at your graph and you say, okay, when x is 1, my y value is either going to be 5 or 8. In the table, you already have the value when x is 1, y is 5. So that means the other one has to be when x is 1, y is 8. To do B is the same thing. When x is some value, y is 4.
So it can either be 4, 3, or 4, 5, or 4. I mean 4, 7.
It can either be 3, 4, 5, 4, or 7, 4. And if you take a look, 7, 4 is already taken, and 3, 4 is already taken, so that means B has to be 5. Okay? Now it says that the mean of x is 5 and the mean of y is 4. And it is asking you to draw your line of best fit in the scatter diagram above. How would you draw your line of best fit? What would you need to do?
Through the median, right?
In the middle of the data set.
You would need to do the middle of the data set, but you would need to plot your mean. When x is 5, y is 4, which is right here. What do you do at that point? Who remembers? You circle it and you put an M. You only do this when you have to actually draw your line of best fit by hand, or it tells you in the directions to do that. Okay? And if it does lie on a dot like that particular one does, you just draw right over it, you circle it, and you label it with an M. If it says label it with an L or label it with the P, you got to label it how they want you to label it. Okay? Now you draw your line. And your data, your line should go halfway through your data. Okay? So you don't want to draw a line that looks something like this. Even though it goes through your mean, what's the issue? It doesn't go through your data, so you can't draw that one. You can't draw one that looks like this. Why is that?
It only goes through 2 points.
only goes through 2 points. You need to find the best line of fit that actually goes through your mean point, and half your data lies above the line, half your data lies below the line. And the main thing too, it needs to have a y-intercept. Okay? So maybe roughly there, maybe a little bit lower, but I have 1, 2, 3, 4, 5. I have 6 pieces of data below the line. I have 1, 2, 3, 4, 5, 6, 7 pieces above the line. So that's actually pretty good. I could adjust it a little bit, but that's pretty good. Questions? Now it says use your line, the line that you drew, to estimate the y value when x is 6.5. So what do?
36.5 on the x-axis.
And then see what?
Where
Where
it hits the line.
it hits the line. So when I go up, mine hits it a little bit under 3, so maybe about 2.8. And these types of problems, it would be, give or take one or the other, like 1 or 2 points, okay? Maybe even 3, it just depends. Questions on this? So, correlation. That was the process going through your calculator. You want to make sure that your diagnostic is on, so that way you can see your R. It also gives you your line of best fit, which is your line that goes through your data, crossing through your mean, and it's also used for predictions. Okay? With the ones that for predictions, you can only make the predictions if it lies within your data. If they asked you to find the y value for an x value that was like 11 or 12, could you do it?
No, it's not on the x-axis.
It's not so much as on your x-axis, it's not within your data. Okay? Because that equation is based off of your data. If we had more, it could very well change that equation drastically. So we couldn't use that to predict something like 12 or 24. Only anything that was in between 0 and 10. Okay?